All right, today starts our unit on similarity. We're going to first kind of get into similarity, just kind of reviewing a little bit about ratios and proportion and scale factor. So first up, we're going to talk about a ratio, and I'm going to kind of just describe it in the best way I can, kind of non-mathematically. Basically, a ratio is just a statement of how two numbers compare. Now, a ratio is usually expressed as a fraction, so a lot of students kind of get a little scared or worried when they see the word ratio. But again, I just cannot stress to you enough that a ratio is just a fraction. So it's just comparing two numbers. Now, we have two ratios that have the same, that are simplified, and they have the same form, that they are called equivalent ratios. So two ratios that reduce to the same thing are equivalent ratios. So, for example, the ratio 7 to 14 and 1 over 2, those are equivalent. There are four ways ratios can be written. You can write a ratio as 3 to 5 with the semicolon. You can write the words 3 to 5. You can write it as a fraction, which is probably the most popular. Or you can write it in words, 3 out of 5. So again, the most common way is the fraction. Right here. All right, so to simplify ratios, huge step before you even start simplifying is you have to make sure everything's in the same units. So we've got to simplify. Let's make sure, yes, 76 centimeters to 8 centimeters. So basically, when you're reducing a fraction, reducing a ratio, you're just dividing. And your calculator is going to do all of this for you. You're going to hit 76 divided by 8. And you're going to hit math, enter, enter, and it's going to turn it into a fraction for you. And that's going to reduce to 19 over 2. And that's your simplified ratio. 4 meters to 18 meters. So basically you have 4 over 18. If you take a 2 out of both of those, it's going to reduce to 2/9. And like I said, you can write your answer in either form. Like I could then write 2 to 9 as well if I wanted to. It would be the same thing. In C, we have 4 feet to 24 inches. Uh-oh, we don't have the same units. So you have the option. You can turn 24 inches here into feet, or you can turn feet into inches. It doesn't matter. However, to keep from getting decimals when you convert, you need to convert into smaller units. That will help you get to decimals. So I tend to always convert smaller. It may be different for you. So like I said, you decide. There are 12 inches and in every foot. So what I have to do is multiply this by 12, and I would get 48 inches over 24 inches. So again, that's 48 over 24, which is going to reduce to 2 over 1. That's your reduced ratio. Next, 33 yards to 9 feet. Well, there are 3 feet for every 1 yard. So basically what you have to do is you have to multiply this by 3, and then you get 99 feet over 9 feet. And that's going to reduce to 11 over 1. So simplifying ratios, you can notice it's just like simplifying fractions. So it should look very similar. However, you got to be careful on the units. So when we're calling it a ratio, it's just kind of a fraction that's having to deal with measurements, and we're going to apply it to our geometric figures. Now, we can always also extend these ratios. An extended ratio are ratios that go beyond comparing just two numbers. So typically you use extended ratios when you're comparing geometric figures. And what we're going to do with these geometric figures are we're going to use ratios to help us find measurements. All right. So let's look at it here. The measures in example 2, the measures of the angles in triangle BCD are in the extended ratio of 2 to 3 to 4. Find the measures of the angles. So basically, you have a triangle. You know that all of these angles in here, we all know by now, they all add up to 180 degrees. So inside every triangle, so watch how I set this up. It's going to be the same every time. Inside of every triangle, there are always 3 angles, and we know that the sum of all interior angles is 180 degrees. So right now, the question is to find the measure of the angles. So right now, look, we don't know what the measures of the angles are. So remember in math, when we don't know something, we use the lovely variable x to stand for an unknown. Now, we have to have something, though, here to help us still solve. Well, we don't know the actual measurements, however, we are given the information of the ratio. So you're going to use the ratio to help you determine the actual measurement. So there you go. Now you're going to combine all those like terms. 2 plus 3 is 5, plus 4 is 9 x's. You're going to divide by 9. Your x is going to be 20. So find the measures of all the angles. So what you have to do is take this unknown, and what that is it's basically your unknown, what your variable is what has been taken out of what the common denominator was between all of those angles. So basically 20 was factored out of all of the angles. So we have to put it back in, which means we have to multiply it back in. So if you go 2 times 20, you get 40 degrees. 3 times 20, you get 60 degrees. 4 times 20, you get 80 degrees. Now, of course, there's always a good way to check this because you know all of the measures must equal 180. So when you do this math, if your sum doesn't come up to 180 at the end, then you've done something incorrect. You need to go back and check. So now I would like you to work on example 3 yourself and come to class tomorrow with it complete. Now, we can also use this with perimeter. So let me just review, and because this is not on the chart, but perimeter is 2 times the length plus 2 times the width. Because remember, for example, in a rectangle, these are the lengths and these are the widths. So actually, you can say that perimeter is length plus width plus width. Or it's the same thing here. I've just simplified it in combined like terms. So in example 4, you are painting barn doors. You know that the perimeter of the doors is 64 feet, and the ratio of the length to the height or the width is 3 to 5. Find the length and the width of the table. So this should say width, okay? All right, so find the length and the width of the table. So first, we're given perimeter. So we're always going to start with the formula. And this is something you're going to have to remember. They give you the perimeter 64 feet. Now watch this. Just like we did with the angles. All right. We don't know what the length and the width are, so we need to use an x to represent the unknown. However, they did give us here that the ratio is 3 to 5. So again, we're going to tag that on to our unknown to help us then solve. So 64 is equal to 2 times 3x is 6x, 2 times 5x is 10x. So go through, simplify. 64 divided by 16 is 4, and we have to find the actual length and the width. So again, you have to take that factor that's been factored out, and you've got to multiply it back in to get the length and the width. So 3 times 4 is 12. That's going to be our length. And 5 times 4 is 20. It's going to be our width. So again, you're going to do example 5 on your own and come to class with it complete. So the next way we can use ratios is to find the ratio of a distance on a number line. So these are super simple. So BC over EF. So we want to find the length of BC here is 2, and the length of EF, 1, 2, 3. So that's the ratio of the length of the segments is 2 to 3. That's all you have to do is count the distance between the beginning and the end and make sure that we're going to simplify it. So again, kind of like the way the progression works is that we start and we set up a fraction when we're comparing numbers. Then we're going to reduce it and we're going to call it a ratio. And then you're going to see what happens when we have two ratios that are the same. What we're going to get into next time is that then it is going to be referred to as the scale factor. So again, we'll get into that later, just so you kind of know how things progress. DE here is 1, EF 1, 2, 3. So there is the ratio of the distances using the number line. Proportions. So this should be a review. We're going to talk about a proportion because we have to then apply it, of course, to our geometric figures. So to jog your memory, a proportion is an equation, hence the equal sign in the middle, that states that two ratios are equal. So again, you can see this proportion here, it's an equation. See the equal sign? And each side of it is a ratio. So this side, that's what a proportion is saying, is that this side is equal to this side. Now, to solve a proportion, we're going to cross multiply. So you should have gotten lots of practice of this last year. Let's go ahead and go through and work these. If you want to go ahead and pause it, you can, or ride along with me. I always like to multiply my x first. If there's only one, it doesn't matter though. So 4 times x is 4x. Multiply the other way. 3 times 16 is 48. Solve for x. Again, cross multiply. Now, when you get more than one term in the numerator or the denominator, you have to be careful because you have to distribute to each and every part. So I want you to notice how when I circled everything, I put the circle around both terms. So when you rewrite this, you need to make sure you have the parentheses around both terms. Don't forget to distribute. 2x, and this is the part that most students forget, to distribute 2 times. If there's 2 terms, you have to distribute 2 times. Now we're going to solve for x. When you're done. Again, cross multiply. There are 2 terms, so I have to make sure that I enclose both terms in the parentheses. Cross multiply. Distribute 2 times, 2 terms, to distribute. Solve for x. Oh, this is 20. There we go, 20, 20, 20. X is equal to 20, so x is 10. So good. I would like you to try D on your own and come to class with it finished. Let's look now at kind of more of a real-world situation. We're going to write and solve a proportion for this problem. So you want to find the total number of hardwood boards that make up 24 lanes at a bowling alley. You know that there are 117 boards in 3 lanes. So 117 boards in 3 lanes. Find the total number of hardwood boards that it takes up to make 24 lanes. So 24 lanes. You want to know, well, how many boards is that? So first thing first, when you set up a proportion typically you know in math that you need a proportion when you are provided with some pieces that kind of correspond, and there's 3 pieces. So you see how we have boards is 1 piece. And then we have lanes, here is 2, and 24 lanes is 3. So we have 3 different pieces, but 2 of them kind of correspond with one another. and they're asking us to find the total number of boards. So we kind of have 4 pieces, and we have some partners here. Next, when you set up a proportion, please label things, because however you build it on the left, it must also be built on the right. So since I went boards over lanes, it has to be boards over lanes. And this setup is going to be very important. So very, very important for what we're going to be doing here the next few days. Make sure the left and the right are built the same way. Now we're going to cross multiply here. So we have 3x. And then we're going to cross multiply here. 17 times 24 is going to give us 2808. Solve for x. So you will have 936 boards in 24 lanes. So that's how you use proportions in real world. So when you say, oh my gosh, I'm never going to need this ever again. See, you never know. Now, of course, we got to get some triangles in there, so you're going to see proportions to solve for missing measurements. Like I said, that's what we typically use ratios for here, is our geometric figures and measurements. So the ratio of 2 side lengths of a triangle are AC to AB, given 3:4. So they gave you the ratio as AC to AB, and that's 3:4. So again, label everything, because the left side must be built just like the right. So here is AC is 3 and AB is 4. So on the actual picture, AC here is 15. That 15 has to go on top because it corresponds here with AC. We don't know what AB is, so we're going to cross multiply. So 3x is equal to, cross multiply, 15 times 4 is 60. So there you go. X is 20. Now sometimes in here, and you can see they've already set up the proportion for you, which is awesome, because then all you have to do is replace the pieces with the actual measurement down here on the diagram. So they said, all right, XW they want on top, so that's 1. WV, oh, well that's what we don't know, is equal to XY is 3 and YZ is 2. Cross multiply. Cross multiply. So there you see your x is 2/3, or if you wanted to write that as 0.67, that's also fine. But there you go, 2/3. All right, lastly, you can also use proportions in scale models. So a scale model is a model that's the same shape as the object it represents, but it's a different size. So again, we're going to talk about similar. That's what we're getting into. And similar means same shape but different size. So you have a scale model. You buy a 3D scale model of the Sun Sphere in Knoxville, Tennessee. This is a building in Knoxville, Tennessee. They call it the Sun Sphere. The actual building is 266 feet tall, but your model is only 20 inches tall. And the diameter of the dome of your scale model is 5.6 inches. What is the diameter of the actual dome? So we're going to first start with the information they gave us. Okay, they told us that the actual thing is 266 feet, and the model is 20 inches. Now, we want to know what is the diameter of the actual dome. So since actual is on top, this is actual dome. The diameter of the model is 5.6 inches. So what's good about a proportion here is that in a proportion, when you cross multiply, as long as you have feet over inches and feet over inches, you don't have to worry about the different units because, see, when you cross multiply, you're going to go feet times inches and then feet times inches, and so it's all going to work out. So you don't have to change the units when you're cross multiplying. Only when you're reducing a single ratio do you have to reduce, not when you don't have to reduce in a proportion. All right, cross multiply. So 20x is equal to, when we cross multiply 266 times 5.6, we get 1489.6. Divide by 20. So x is equal to 74.48 feet. So that's the diameter of the actual dome. So now it wants, well, how many times as tall as your model is the actual building? Well, let's see. How many times as tall as your model is the actual building? So it wants to know how much times bigger is our building than the model. Well, the building is 266 feet. The model is 20 inches. So we need to know the difference there. Well, you see now we have one ratio. So we must simplify here. We need all of the same units. So I'm going to multiply that by 12 because there's 12 inches in a foot, and I'm going to get 3192 over 20. If you divide 3192 divided by 20, you get 159.6. So that's how much times bigger the actual thing is than the model. So the actual sun sphere is about 160 times bigger than the actual model. Sorry, the model, the actual building in the model. All right, that's it. Make sure you finish the examples that I've asked you to finish. That was what, example 3, 5, and example 7D. See you later.